All right, so just connecting hybridized networks together, multiple connections, independent networks. How do we integrate, obviously, on-premise with on-cloud? The questions here are, how do we do security for networking? How do services communicate with each other, either directly or indirectly? Hybridized networks. How do I manage traffic and security for a rapidly expanding number of VPCs? And then what can you use for DNS resolution, both on-premise to cloud and cloud to on-premise? That's where we talk about the Route 53 resolver, by the way. Networking architecture, you can see that in our question yesterday, we talked briefly about VPC endpoints when we were doing the practice exams. Note here that there's also a virtual private gateway, and that we've got Route 53 in place. So a lot of the stuff that we're going to do is going to either terminate on a virtual private gateway, or, just to throw this out there, on a transit gateway. We're going to talk about that. So in this drawing, the top connection is a VPN connection over the internet. The bottom connection is a physical wire that's being run from your data center into a partner location that Amazon has. And in turn, your router, which you're going to have in the direct connect location, is talking to an AWS router, which is then going over a physical connection. Both of these are terminating at a virtual private gateway. Both of these can also terminate at a transit gateway. So when we get to transit gateways, remember that you can also use to terminate direct connect connections and VPN. Now, one thing I also want to point out here is that the VPN connection is running over the internet. So if at 10 p.m. everybody starts downloading Netflix, that used to be true. Isn't it like Disney Plus and everything else now? Remember the good old days when it was just 2 or 3 streaming services? Anyway, moving on. Was that the good old days? I'm not really sure. Anyway, regardless, that direct connect connection is going to have its own dedicated pipe, which is either going to be a subfraction of a gigabit connection, gigabit, 10 gigabit, or 100 gigabit connection. So remember that, by the way, that direct connect connection is not encrypted by default. So while it's not running over the internet, it's not encrypted. You have to run VPN over that direct connect connection in order to encrypt it. You can also use something called MACsec, if I remember correctly. It's an 802 dot something protocol that will allow you to encrypt it if the routers support it. So just something to know is that you can use VPN, or you could actually use something called, I think it's called MACsec, but my memory on that, there's too much to know. All right, so let's talk about these different pieces from that original drawing: VPC endpoints, VPC peering, transit gateway, and then how to manage hybridized networking, and then Route 53. Bunches and bunches. So true, Christian. Okay, this came up in the exam question yesterday. How can my services talk to each other without routing through the public internet? We did this yesterday when we closed, right? Is that right now you see this EC2 instance is going to a NAT gateway to talk through the internet gateway to talk to the public interface for DynamoDB. And you're like, but Michael, isn't DynamoDB in the same data centers as EC2? No. Remember, I mentioned this before, is that there are regional data centers that are not part of the EC2 availability zones that we hook into, that Amazon hosts these third-party services, third-party services. They host DynamoDB and they host S3 in these regional data centers that we're not connected to at all. They have their own public interfaces and connections to the internet. So when we want to talk to them and we're on the EC2 data center and we want to talk to a DynamoDB or an S3, we have to go out the internet to hit the public interfaces for these data centers. Now, how do we change that? Well, with a VPC endpoint, note that I don't need a NAT gateway. I'm going to hit the private NIC that's inside. Well, sometimes it's a NIC, sometimes it's just an entry point, but either way, there's a network interface there. I'm going to hit this endpoint, and the endpoint is going to take me straight into the data center. In other words, I'm going to stay on Amazon's private backbone. I'm not going to go across the public backbone like this is. Now, how many hops away is it from the internet gateway at a data center over to DynamoDB? Probably not a whole lot, but it doesn't matter. You're still exposed, and that might still violate your security policies. Plus, you're shoving bandwidth through that NAT gateway, so you're going to pay for that. You're not going to pay for it here. Well, not as much. Remember, these VPC endpoints, by the way, are virtual endpoints. They're not an actual physical device. They're virtual devices. So they scale and are horizontally redundant. They work automatically, as I like to say. Now, there are two types of interface. Well, I say two types. Hold on. I think they probably added the third one. Yeah. So there's three types. Three types of VPC endpoints, right? There's a gateway endpoint, which is the oldest of the endpoints, and it only covers two services, DynamoDB and S3. Then there's an interface endpoint, which covers a bunch of services, including DynamoDB and S3. And then there's the gateway load balancer endpoint, which, it's a network interface with a private IP address, and it actually will take that IP address from the IP range of your subnet. And it's used for gateway load balancers only. It basically allows you to distribute traffic across multiple appliances, scaling them up and down, but it allows you to basically point towards your third-party security devices for accessibility. Now, you might say to me, Michael, you just said the gateway endpoint has two services and the interface endpoint has like 20 services that it supports, but the interface endpoint also supports the same two services that the gateway endpoint uses. So why would I ever use a gateway endpoint? Well, here's the weird thing. This is all, by the way, a flavor of what AWS calls private link, which is basically their ability to stick a network card inside of your subnets. That's what private link is, right? Now, here's the problem. Gateway endpoints do not take an IP address from your subnet. Interface endpoints take an IP address from your subnet for every single supported service. So if you had 20 services, you're going to lose 20 IP addresses. So yeah, just take that in. So the interface endpoints and the gateway load balancer endpoints are going to take an IP address from your subnet when you set them up, right? So just be mindful of that. The gateway endpoint doesn't. It's just an entry in a route table. That's all it is, right? If you want to see this, let me figure out 1 second. Link.
I missed it. So what is the gateway load balancer endpoint different from the other two? How does the gateway load balancer endpoint different from the gateway endpoint or interface endpoint?
So Vinod, the gateway endpoint and the interface endpoints are only for AWS services like S3, DynamoDB, Systems Manager, that kind of thing. The gateway load balancer endpoint is for gateway load balancers, which is not any AWS service, right? That's the actual third-party appliances that you launch for gateway load balancers. So like if you launch, like for example, I'm trying to think of one. If you launch like a Fortinet or some other device that does deep packet inspection, and you want to create a private connection to it because it's actually out in a public data center, which is where it would run if it was a load balancer, you would actually just create this load balancer endpoint. So instead of trying to connect to that thing over the internet, you're going to connect to it privately, right? So the one on the right is only for gateway load balancers only. The other two are for AWS services. Is that clear?
Yes. Thanks.
Okay. So note that this is the list of services that integrate in with interface endpoints, not gateway endpoints. Remember, gateway endpoints only handle S3 and DynamoDB, right? So here, notice that it's like look this, there's a huge list of services here. CloudWatch, Code Artifact, Code Build, EBS Direct APIs, right? Elastic File System. There's a lot that you can set up, has a private link so that you don't have to. And remember, not every application is going to be talking to every single service. So it's not like you got to set 30 IP addresses up with 30 virtual endpoints inside of every single subnet. It just depends on what your application is calling, right? So this may seem like, well, Michael, what if I got to set up, you don't have to set up 50 of these. Don't worry about it, right? Just set up private links when the situation calls for it and when you absolutely have to, right?
So does the private link replace VPC endpoint?
Vinod, private link is the name of the technology that powers all of these.
Oh,
So again, it's confusing because Amazon likes to do this. They like to advertise it as if it's a separate product, but all that is the name of the underlying technology that makes all this possible, which is we now have the ability to stick a network card inside your subnets and have it redirect to other places.
okay.
That's
Yeah,
all
I saw
private
on
link.
that slide, like the type of connections for interface endpoint. So does it mean like the interface endpoint and private link, are they one and the same? Interface endpoint and private link, are they the same?
No, so gateway endpoints, interface endpoints, and load balancer endpoints are all powered by private link. Right? That's all it is. Private link is the underlying technology that makes this work. And all it is the ability to stick a network card inside of a subnet. So gateway endpoint is a flavor of private link. Interface endpoint is a flavor of private link. Gateway load balancer endpoint is just a flavor of private link. Let's see if this helps. So see here, what they're doing is that you've got internet gateway at the top, and then you've got a gateway endpoint, right? A gateway endpoint is not a load balancer endpoint because it's not a gateway load balancer. It just says gateway endpoint. And it's not an interface endpoint, right? This is just where they've stuck a network card at the edge, and the network card is actually directly and privately connected to the S3 data center, privately connected to the DynamoDB data center. And note that all they did is they changed the routing table for the private subnet to say, look, if you're looking for S3, blah, 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 go over here to the virtual private gateway endpoint. If you're looking for DynamoDB, just go to the VPC endpoint. That's all they're doing is they're just saying, hey, we're just routing you out through these private interfaces instead of going across the public internet. So this is just a way of controlling traffic flow. So this is gateway VPC endpoints. This is interface VPC endpoints. So we're now on to a second flavor, right? And so what happens here is it's really just the same thing, but here's the distinction. Instead of modifying your routing table, you're now just connecting over to 172.16.1.6 because they're now changing DNS, right? So they're now basically rerouting DNS here on your local network and saying, look, if you're looking for S3, you're going to get routed to 172.16.1.6. So notice they didn't change the routing tables. Now DNS is taking over and saying, if you're looking for S3, whatever, we're going to intercept that call and we're going to redirect you over here. And so this is all part of the private link technology suite. Now, if they were smart, they would have added a third slide that said, here's the gateway load balancer, right, endpoint, because we just talked about gateway VPC endpoints. We just talked about interface VPC endpoints. What about the gateway load balancer VPC endpoint? Well, they don't have a slide for that. They don't have that here. But that would be the third slide that we would show. And it would look remarkably like this, actually, because this is exactly how the gateway load balancer endpoint works, is it works exactly like an interface VPC endpoint. Now, mention this is that this is all part of the private link family. Again, this is the underlying technology that allows them to just stick a network card anywhere in your subnet and have it redirect to another service. So here what they're doing is that instead of actually using either the gateway, the interface, or the gateway load balancer VPC endpoints, what they're doing is they're actually having an EC2 instance point to a private link interface that's actually going to a network load balancer in somebody else's account or in just another VPC in your account. And so this is a way in which you can actually use Amazon's private backbone instead of having to expose that network load balancer across the internet. So private link gives you the ability to privately link your network interfaces in with somebody else's VPC or your own VPCs without running that traffic across the internet. So that's why it's called private link, is it is a private link between you and some other location, between you and some other service, between you and some other, load balancer, right? So this is all part of the private link technology set.
So which is, sir, just to clarify, so which is what before this private link terminology was out, it was a VPC endpoint, right?
Yes.
So, and VPC endpoint, that is what it was doing, right? It was providing private connectivity using Amazon's backbone without having to go through internet. So is that VPC endpoint terminology has been, how to say that the private link is a better term to indicate the same thing?
No, we're still using the term VPC endpoints. So we got gateways, we got interfaces, we got global, gateway load balancer, VPC endpoints. We're still using the term VPC endpoints. The distinction here is that you can also use private link for things that are other than VPC endpoints. So instead of pointing to AWS services, you can now point to your own proprietary applications, including a network load balancer. I can't remember exactly what private link can hook into, but I think it's an ALB, NLB, and something else. But like you can actually take these entry points and stick them in your subnet and point them somewhere else. You don't have to point them just to AWS services, but they are no longer VPC endpoints at that point in time, right?
I see.
Yeah, it's an interface endpoint that you've managed yourself.
Mm-hmm.
So for example, instead of pointing to the S3 API, you could actually have an interface endpoint that hooks directly into an S3 bucket. So what this means is that you can now use that private link technology to point network cards to whatever services you want to connect to. It doesn't just have to be Amazon's APIs. It can now be other services that you designate.
Gotcha. And sir, just very quickly, the terminology gateway versus interface. How are they different?
All right. So gateway endpoints, this was the first one they came out with, and I want to say this is like 6 years ago. This is the first one they came out with. This gateway VPC endpoint only serves S3 and DynamoDB. The new one, which this one is definitely like fueled by private link. This one will support any AWS API that's on this list. And by the way, that includes S3, and that includes DynamoDB up here as well. Where are you? Well, it used to include DynamoDB. Huh, maybe I missed it. Hold on. Am I not spelling it right? Huh. That's weird. Okay, I stand corrected. That doesn't sound right though. I just hooked it into DynamoDB the other day. Anyway, regardless, so the gateway interface endpoint only supports 2 services, DynamoDB and S3. The interface endpoint supports anything that's currently on this list, including DynamoDB, which I'm not sure it's why it's not here. Maybe I'm not searching correctly. Anyway, so that's the distinction, right? Is that gateway only supports 2 services, interface supports a broad swath of services.
Gotcha. Thank you, sir.
Hey, Michael. So if I wanted to securely connect to RDS from EC2, I would want to set up an interface in my VPC. so that I can like establish that secure connection between EC2 and RDS, or am I talking about a different scenario?
Well, let's be clear. It uses TLS everywhere, right? So you're going to have a secure connection. If you're talking about not running it over the internet, then absolutely, right? Because I think you could argue it's more secure to keep it private, right? So I just want to make sure that's clear. You still have TLS in play if you're even talking to the public interfaces. But if you wanted to connect to RDS and you didn't want to like have it like run that, across the internet, yes, you would use a private interface. Now, just to say this, RDS, like just to be clear about this, Timothy, is that we're talking about the RDS API. When you connect to a database, that database has a DNS entry, and that database, RDS, for example, is sitting inside of an EC2 system. That EC2 system is probably going to be sitting in the same VPC, same subnet, correct?
Yeah, that makes sense.
Right. So it's a good point that you bring up, because it can get confusing, because it's like when we talk about gateway endpoints, interface endpoints, we're talking purely about API access. Now, if it's S3 or DynamoDB, well, those are API driven protocols, meaning that you're not going to connect to them using an SQL workbench, right? You're going to connect to them using the DynamoDB API and the S3 API. So in that case, all traffic to those services would go through the interface endpoint. With RDS, since it's running an EC2 instance and it has an SQL engine that you connect to separately from the RDS API, you have to manage that network traffic differently than the RDS API traffic, which you could then run through an interface endpoint, right? So just, you have to, if it's sitting inside of an EC2 virtual machine, then the virtual machine is going to be where the network traffic goes. If it's not sitting inside of a virtual machine, then most of the time it's going to go through the API. So that's where
So
an
like,
interface or gateway endpoint would come into play.
So like a scenario for that would be like if you were using Aurora serverless.
Exactly. Well, that's the thing that gets weird though, right? Is that Aurora is serverless, but we got to be careful with serverless, because that just means hidden servers. So you're still connecting with an SQL engine, you just are not managing the servers, but that's no different than RDS. You just happen to know that RDS is running into your thing, right? So running into your like subnet. So my point being is that if you're connecting to a separate system like Kubernetes, or a separate system like RDS, which has its own database engines, if you're connecting to a separate system, that is actually distinct traffic from API calls. So only truly fully managed systems use API calls to actually pull data and manipulate data. Any other system like Kubernetes or a database engine, you're going to be connecting to some kind of location that has an operating system on it. So it's on a case-by-case basis.
Yeah, that makes sense. Thank you, Michael. I appreciate it.
Yeah. So if it's serverless, then someone's got the servers and you're going to be connecting to the server to get access to that data, right? But if it's a highly managed system like DynamoDB or whatever, where you don't even know where those servers are, you are not running inside of an operating system, you're literally just connecting to those pieces through the API. So there's only, by the way, a few cases where you're going to be connecting to a server, even if you can't see it. That would be ECS, EKS, that would be Aurora serverless, and that would be any EC2 instance, and that would be EMR. Those are the only services that you're going to be connecting to an operating system. Otherwise, for example, Lambda, you're going to run that purely through an API. You'll never see those servers and you'll never be able to connect them, and you don't have to go to a location to execute them. So there's only like 6 services where you actually have to connect to an operating system, even if you can't see the operating system. That's a good question, actually, Timothy. Most people don't think of it that way. Cool. All right, have I confused everyone sufficiently on this? Right? My job wasn't to provide clarity. It was to provide confusion. All right, just remember this. Private link is the underlying technology that lets them put network interfaces anywhere they want to. Whether that network interface points to AWS APIs or that network interface points towards something that you've designated, that's up to you. So if you want to like dive into this, this is all under the private link umbrella, and all the documentation says private link on it as well. Okay. And by the way, the whole point of this was just to create private links so that your traffic didn't flow over the internet. So hopefully that's a good summation of everything. Okay. Now let's talk about VPC pairing. So this is also another way to create private like interconnects, but this one is mainly focused on how you create interconnects between your different VPCs. Because remember, by default, subnets inside of a VPC can all talk to each other. But by default, VPCs cannot talk to other VPCs. So then how do we link them together? Well, this is where VPC peering comes in. You can actually take VPCs and create connections between them. The only catch is that the network ranges cannot overlap. So you can't take a 10.1/16 and a 10.1/16 and hook them together. You can't do that. If you do that, they won't be able to find each other because they're each going to think that they're local. Now, the other thing to be aware of is that they do not support transitive peering. So in this particular diagram, just because A can talk to B and C can talk to B does not mean that A and C are allowed to talk to each other. AWS does not allow traffic to pass through another network to get to another network. They don't support that. They will drop that traffic on the floor. So if the destination, if somebody in VPC A at 10.1 decides to go over to 10.2, which is VPC C, there's no route to that. Even if you set up a route to that, VPC B is going to block it. They will not allow you to target traffic inside of a VPC that is not destined for that VPC. So you can't hop through, you can't do what's called transitive peering. You can't hop through a bunch of transitions, right? By the way, these VPCs can be linked together no matter where they are in the world. So if you want to hook up one in Melbourne with one in Canada, you can do that. Just remember, it is going to go over Amazon's high-speed backbone, but we do still have physics to deal with. So don't expect instantaneous transfer. We have yet to perfect the Ansible, but oddly enough, we're actually closer than I would think about instantaneous transmission. It's kind of weird. Look up quantum entanglement if you ever want to see anything on that. It really blows my mind what we are close to accomplishing as far as like near instantaneous, faster than light transmission. So weird. Truth is far stranger than fiction. Anyway, moving on.
So I have a hypothetical question.
Sure.
Since it supports cross-account peering, if I have an account in unclass environment I'm talking about, if I have an account in AWS and also I have an account and another account in AWS GovCloud, which is also, by the way, unclass.
No, nope. I can answer that for you right now. Whatever you're about to do between the public sector and the private sector, if they're not both in GovCloud, you can't hook them together.
Is the AWS GovCloud only available to government?
Yeah, well, it's available to the government and anybody who has a status and affiliation for government contracts.
Oh, gotcha.
Yeah,
I see what you mean. Yeah.
So you can't cross the streams, Vinod. You can't take any of GovCloud's infrastructure and privately hook it up to any of AWS's like public commercial infrastructure.
Okay, so makes sense. Thank you.
Yeah. Now you could set up a VPN connection if you wanted to between AWS and the GovCloud, but you'd have to use EC2 instances for at least one end of that, if I remember correctly. So I think that's true.
Oh, okay, thank you.
Yeah. Note here that when you peer connections together, that there's a route table in for each of them. So just be mindful that you actually end up going into a router, which just then connects the systems together. The only problem with this, just so you know, is that when you start doing stuff like this, if you have 500 VPCs, if you're doing a hub and spoke model, like you're going to hub and spoke, right? So you're centralizing everything in, that's actually pretty straightforward. If you start doing a mesh network like this, you're not going to want to do that. just so we're clear, you're going to want to use Transit Gateway if you're going to do this. Okay. Transit Gateway will allow you to do this a lot easier if you're going to do a full mesh peering than even if you do this. And just to say this, Transit Gateway is also even better at this than VPC peering. So I know that everyone's comfortable with VPC peering because it's one, it's a little more simple, and two, we're familiar with it because it's been around for like 10 years. But please note that unless you're just wed to VPC peering, or if you're trying to do this, please switch over to Transit Gateway, which is the next thing we're about to talk about. Transit Gateway is 100 times easier for a full mesh network than managing the like 5,000 connections you need to do VPC peering, especially for large enterprises. Plus, you get more control, more routability, and you get better control over VPC, VPN, and direct connect connections. So I cannot tout Transit Gateway's values enough. And before I even talk about Transit Gateway, I'm just going to share this with you, is that there is a Transit Gateway workshop, which I can't spell, for AWS. So just know there's a network firewall workshop that also includes Transit Gateway. And there's also, if you just search for Transit Gateway workshop, there's a couple of like workshops out here. These are all published by AWS, by the way. So feel free to come out here and like, grab something like this if you need to get more experience. This will require a free account. This will cost you, I think it's 50 cents, as long as you don't walk away from anything. Remember, I always caveat it with that. But just know that there are some Transit Gateway workshops out there. Now, since I'm already talking about Transit Gateway, let's talk about Transit Gateway. Since VPC peering and Transit Gateway are kind of two sides of the same coin. So if you're not doing Transit Gateway, these are all the connections that you now have to manage and connect in order to get a VPN and a direct connect to be part of all of your many VPCs and to get all of these VPCs to talk to each other if you're doing a mesh network, right? So if you got 6 VPCs, you got 15 different peering connections, not including the 6 virtual interfaces or VIFs, plus the 12 physical tunnels that you have with, VPN and direct connect, right? So you got 6 logical VPNs. Now with a Transit Gateway, this all shifts. So what happens is that the Transit Gateway acts as a router and you attach networks to this router. And what will happen is that it starts routing traffic between all these networks based on rules that you specify. So if you want your VPN to talk only to your non-production stuff, and you want direct connect to only talk to your production stuff, you get to control the routing of the flow of packets between all these systems based on whatever rules or setup you specify. Now be aware that Transit Gateway will stick a NIC in each of these places that you, right, on the VPCs at least. It's going to have at least one NIC in every availability zone in order to control traffic throughout the entire availability zone. So this is just really just a routing layer, and you can stack Transit Gateways on top of each other. You can also connect Transit Gateways in one region to a Transit Gateway in another region. So think of it as a hub that controls how traffic is routed across all of the connected networks. So this is truly a hub and spoke model, and this is the hub you want to use, right? So everybody only has to have one connection to the Transit Gateway. You don't have to have a connection to anything else. The Transit Gateway will handle making connections to everything else on layer 3 based on what you've set it up for. Now it will, by the way, support IPv4 and IPv6, and you can actually configure route tables to propagate for all of your attached VPCs and attached VPN connections. You can also add static routes if you want to. So you don't have to do dynamic routing unless you're really interested in that. So you've got Transit Gateway. It has its own route table rules, right? And you attach the route tables, the VPCs, the VPN connections, and the direct connect gateways to this system. That's all. So this will manage all of your hybridized connections, and it will manage your on-cloud connections as well. So just remember that you need these attachments in order to, they need to be attached to the gateway in order to function. Now, the cool thing about this is that you can isolate this connectivity however you want. If you want everybody to talk to everybody else, you can do that. If you want it so that, you know, half the VPCs can't talk to the other half, or you want to control whether or not they can talk to VPN or not talk to VPN. If you want to like isolate all that traffic so they can't talk to each other, but they can all talk to VPN, you can do that. This is a fully controllable, routable layer. So you can set this up exactly the way you want to, as if you have full access to a router on AWS. And a reminder that this can hook into other transit gateways in other regions. So you can route that way as well if you want to. So this is way better than VPC peering, simply because it's one connection for each of your customer networks, whether it's a VPN, a direct connect, or a VPC, or a subnet inside of a VPC. Highly recommend you run through a free workshop if this is something you're even think you're going to remotely deal with. But Transit Gateway is a really great product. It takes a little bit to get it set up, but once it's there, it's good. You just make tweaks at that point in time.
So how many VPC, how to say, when do you recommend this over VPC peering? Like how many VPC peering we have that it's considered, okay, this is at this point we should.
I would say this is
transition.
if you're just starting out, just use Transit Gateway. Don't use
Mhm.
VPC peering at all unless you have to. That would be my recommendation. Now,
But I
if
heard
you're
some that
used,
this,
go ahead.
I heard this transit gateway is not free, unlike VPC peering. They're not correct?
That's true. It isn't necessarily free. There are costs like I can't remember. I think it's per like attached network or something per month. So you're
Yeah.
right. It's not necessarily free. So, but the problem is that the management overhead from VPC peering, I would say once you get past like about 10 connected VPC networks, is going to make Transit Gateway worth it. Just because it's not free doesn't mean it's expensive, right? I mean, I think I spent $2 on a Transit Gateway with 20 connected attachments. So $20 a month, right?
Okay.
Yeah. So that's something to keep in mind, right? Is that you do have to run the numbers if you want to see if it's worth it. But I will tell you that above 10 VPC connections, because if I remember correctly, 10 is going to get you 28. Is that right? 28 different connections that you have to do. So just know that managing those can be it can be a big headache. Now you'd think it would just be fire and forget, but it's not, right? Especially as VPCs are coming and going. So I would say that's a threshold. If you're managing 10 VPCs in a mesh network, and or you can go ahead and foot the cost, I would go ahead and just start with Transit Gateway. All right. So let's talk a little bit about the hybrid options, because we keep making statements about like what it is to connect things up to AWS. I don't even know that we've even talked about VPN or Direct Connect, but let's maybe do that now, actually. So know that you can actually do a VPN connection site to site from device to device into AWS. You've actually got 3 options of how to terminate that server into AWS. You can use a virtual private gateway. You could run it on your own EC2 instance, or you could terminate it into a transit gateway. I'm just going to tell you, please don't run it on your own EC2 instance. We've done that for years, for so long. Just at least use a virtual private gateway, even if you don't want to pay for a transit gateway, right? Just terminate it into a VPG instead. That being said, options 1 and 3 are probably the most legitimate low-cost options that you can use. This does run across the internet, is IPsec. If you need GRE, by the way, version of VPN, you are not going to use any AWS options. AWS only supports IPsec and IKE version 2. If you want something other than IKE version 2 and something other than IPsec, you cannot use any AWS structure for that. Roll your own EC2 instance at that point. Now, that's an over internet option. What about if I want to run that direct cable, Michael, that you were talking about? Because that's 100 gigabits per second, because I've got money to burn. Just kidding. Because I need it for my company, right? just know that you can run that direct connection. It is going to require a customer gateway device, and you're going to need a customer router inside the partner data center. So just know there's actually 2 devices. Wait, how's that? Why does that not show that? Oh, there it is. Never mind. So there's the customer router. Notice that it is then routing to an AWS router. So don't worry. The direct connect partner will actually help you set all that up. This, by the way, is going to reduce your transfer costs because AWS charges you less if you run over your own pipe for pulling data out of AWS. Note that you can get a fraction of a gig, a 10 gig, and 100 gigabit connection. So whatever you need to do there. It is associated with the region. And just like the VPN connection, you can terminate into a virtual private gateway, or you can terminate what's called a direct connect gateway, which I do not recommend, or you can terminate into a transit gateway, which again, if you're managing multiple connections, that might be super attractive, right? So just know, just like VPN, you can terminate into a variety of different devices. The only difference between this and VPN is that VPN doesn't have its own like VPN gateway. It uses a virtual private gateway, just like this one does. But Direct Connect actually has its own Direct Connect gateway you can go into. Do note, by the way, that they have private virtual interfaces, transit virtual interfaces, and they don't list it here, but they actually also have public virtual interfaces. Those public VIFs, by the way, usually go to things like the S3 API or DynamoDB API. So you do have public VIFs if you want them. Okay. All right, so that's ways of connecting either through VPN or direct connect your off-premise, your on-premise network into on cloud. So, okay. Last question. What if you want to actually get to resources that are on your data center, or you're in your data center and you want to go over across these private connections to get into AWS? Like, how does that happen? Well, here's the deal. So with Route 53, what's going to happen is that, Route 53 is AWS's DNS service. So it is a full registrar, which means you can buy domain names. You can resolve domain names to IP addresses. You can route requests based on latency, health checks, other criteria, like whatever you're interested in doing. Now, you can also host zones like, Amazon.com, example.com, whatever, publicly. So it means that people can resolve them publicly, or you can do private DNS queries where there's, because remember, AWS takes one of your IP addresses for DNS, right? Off the subnet. So you can actually do private hosted zones. And what that does is when you do a resolution, like you're going to www.amazon.com, instead of trying to take you to the public interface, you can have it resolved to say like a private interface inside of AWS, right? And so it will integrate with on-premise private zones using like forwarding rules and whatnot. So just know that the public hosted zones, you can do those global routing policies. Private hosted zones allow you to like route to private resources. Now, if someone comes to you and says, Michael, we're hosting a public application and I need advanced routing policies. I need to geofence somebody who's in France to only go to the Germany data center. I need to geofence so that if they're in Brazil, they don't go anywhere but the Brazilian data center. Or they might say, look, I want whichever data center is fastest, I want them to either go to Spain or Germany if they're in France, but only to the fastest data center. That's all part of routing policies. So note that AWS allows you to create these really cool routing policies. The simple one is just straightforward. You get a name, you get back a response. But failover says, look, if one of these data centers fails, route all traffic to the other data center. That's failover routing. You can also do it by location. A European user can go over to the European data center. An America's user could go over to the North American data center. You can do this based on geolocation. You can do it based on what are they closest to? Are you closest to Germany? Great, go to Germany. Right? Are you closest to, Mumbai? Then go to Mumbai. right? So geo proximity, and then there's latency-based routing, which you might think that geo proximity and latency-based routing are the same, but imagine, like you're in France, and Spain is 30 milliseconds faster than Germany, but you're about equidistant from both locations, right? That happens all the time. So sometimes the further data center is faster because your pipes are faster, and the closest data center might be having some issue or a slowdown, and it's not the fastest. So latency based says, like, I want the fastest one. And then if you have some kind of like round robin failover, you can actually do multi-value routing, which is basically says, look, I'm going to route to these like 3 locations or 4 locations. If one of these locations turns unhealthy, I'll stop it. And then there's weighted routing, which says, hey, you know what? This data center has 9 times as many resources as the other data center. So let's just wait between these 2. Or you could be doing a deployment. You got a new environment and you want to turn the dial so that 5% of your traffic goes to the new location. And by the way, this could all be in the same data center. It doesn't have to be in a different data center, right? It could be in the same data center, maybe different ELBs, right? And so you got a new copy of your environment. You're doing some kind of canary deployment where you're slowly moving traffic over into the new environment as long as everything looks clear. So this is all for public routing policies. These are 7 different ways you can actually control DNS routing inside your environment. And that's all public. Just know that if you're inside AWS and you want to get access to DNS inside your on-premise, or if you're on-premise and you want to get DNS resolution to AWS, they have these things called resolver endpoints that you can use to resolve DNS queries to your private resources or resolve queries that are happening inside of your on-premise data center into AWS resources. So just know that you can actually control DNS resolution going to on-prem or to AWS. So either one. And by the way, the network could be the VPC itself. It could be another peered VPC. It could be an on-premise network that's connected with Direct Connect, VPN, or even a NAT gateway. So just know that you can control DNS resolution whichever way you need to make sure that you're resolving your resources the correct way. Okay. All right, knowledge check. What is the name? Like when you have a network connection connected to a transit gateway, what is that called? What is that network connection to a transit gateway? Yeah, good. That's called an attachment. Perfect. That's exactly right. It's called an attachment. Okay. What are the 2 components of an AWS VPN connection? Not necessarily site to site, it was just a VPN connection. What are the 2 things you need? You need something on the on-premise side, and you need something on the AWS side. What are the 2 things we use? Okay, A and C, right? Customer gateway device, virtual private gateway. So customer gateway device is just a device that can handle VPN on the customer side, and then the virtual gateway device is the connection to AWS, right? Good. What is true of VPC peering connections? What is true about VPC peering connections? What do we know? What's the weakness of them? Okay, B and D. The connections are one-to-one and they can span accounts. That is accurate. Good. How can an application running in a VPC access Amazon S3 without internet access? There's two options here. Remember, S3 is one of those services that has two options for the private link stuff. What are the two possibilities that you can use to make sure that S3 API traffic only goes over Amazon's backbone? Good. Interface and gateway endpoints, right? Remember, gateway endpoints only handle DynamoDB and S3. Interface endpoints handle a whole broad swath of services. By the way, I'm going to look up that whole thing with interface endpoints because I remember distinctly, not that my memory is the best, adding in DynamoDB with an interface endpoint. So I'm kind of curious as to what happened there, whether I'm misremembering or the documentation is wrong. So I'll look that up at the next break. Okay, end of module 10. Great questions, by the way. Great ways of thinking. Does anyone have any other questions about anything that we've covered thus far with this networking piece? No? All right. Okay, so well then we're going to talk about serverless. Let me stop the recording. Ooh, I got everything uploaded yesterday. So excited.